Have you ever looked up at the night sky and wondered about the vast emptiness between the stars and planets? It seems like a great dark void, stretching on forever. But what if I told you there are special places hidden within that emptiness? These places are not planets or stars, but points of perfect balance. They are invisible gateways in space where the pull of gravity from celestial bodies cancels out in a delicate dance. These are the Lagrange points, and they hold a profound fascination for scientists and space explorers alike. They represent a kind of cosmic secret waiting to be unlocked. These points are named after the brilliant mathematician Joseph Louis Lagrange. He discovered them over 2 centuries ago, long before we had the technology to even dream of reaching them. He imagined them through the pure power of mathematics, predicting their existence with equations on paper. It was a remarkable feat of intellect. Lagrange realized that in any system with 2 large orbiting bodies, like the Sun and the Earth, or the Earth and the Moon, there must be 5 specific points where a much smaller object could stay relatively still. It's like finding a perfectly calm spot in the middle of a swirling cosmic river. For decades, these points were purely theoretical, a curious footnote in the complex mathematics of celestial mechanics. They were a fascinating concept, but they remained out of reach. But as our ambition grew and our rockets became more powerful, the idea of Lagrange points transformed into a tangible strategic objective for the future of space exploration and our expansion into the cosmos. The most famous resident of a Lagrange point right now is, without a doubt, the James Webb Space Telescope. This magnificent observatory is a real testament to the practical power of Lagrange's discovery. The L2 point, located about 1.5 million kilometers away on the far side of the Earth from the Sun, is a perfect location for staying cool, allowing the telescope to use a single giant sun shield to block out their light and heat at the same time. It allows Webb to peer back in time over 13.5 billion years, capturing the faint light from the very first galaxies to form after the Big Bang. If L2 is our eye on the universe, then L1 is our dedicated sentinel, keeping a constant, unblinking watch on our own star. The Sun can unleash violent solar storms which send billions of tons of charged particles hurtling through space. Spacecraft like the Solar and Heliospheric Observatory, or SOHO, have been stationed at L1 for years, monitoring the Sun's activity around the clock. The data sent back allows power grid operators to take precautions to prevent widespread blackouts and warns airlines to reroute flights away from polar regions. Before we build sprawling cities in space, we will likely use Lagrange points as vital transportation hubs and staging posts. A space station placed at one of the Earth-Moon Lagrange points could serve as a midway point where spacecraft could dock, refuel, and prepare for the next leg of their journey. Imagine a journey to Mars in the future. Instead of launching a massive, fully fueled rocket directly from Earth, the interplanetary ship would be assembled at a Lagrange point station built in space, free from the constraints of Earth's powerful gravity. Lagrange points can become the sites of vast, automated factories and refineries, processing raw materials mined from asteroids and the Moon in the vacuum of space. Asteroids rich in metals like iron, nickel, and platinum could be nudged from their orbits and brought to this location for processing. One of the most valuable resources in space is water. The poles of the Moon and many asteroids contain vast quantities of water ice. This depot would become a cosmic fuel station where interplanetary ships could refuel for their long voyages. The grandest vision for Lagrange point colonization is the creation of entire worlds in space. Gerard K. O'Neill's concept of a giant rotating habitat, known as an O'Neill cylinder, remains one of the most inspiring ideas in space exploration. The interior could be landscaped with soil, trees, rivers, and lakes. This rotation would create artificial gravity on the inner surface, allowing for a comfortable, Earth-like environment where people could live without the bone and muscle loss associated with zero gravity. They would be self-sufficient worlds, growing their own food and recycling their own resources. Building such a structure would be the most ambitious engineering project in human history, requiring decades of work and international cooperation on an unprecedented scale. The stable Lagrange points provide the perfect location for such a long-term construction project, the ideal place to build a new home, a safe harbor in the cosmos. While the promise of Lagrange points is immense, transforming these visions into reality presents formidable technical challenges. The cost of lifting every kilogram into orbit would make any large-scale construction project prohibitively expensive. The most viable solution is to use resources already in space. We need to design robotic miners, processing plants, and manufacturing facilities that can operate reliably in harsh environments. Beyond technical challenges, we must consider the profound human element. The psychological and physiological effects of long-duration spaceflight in isolated artificial environments are still not fully understood. The space environment outside Earth's protective magnetic field is filled with harmful radiation. Shielding future colonists from cosmic rays and solar particle events is one of the most critical challenges. From a purely mathematical curiosity born in the mind of an 18th century genius to the active sights of our most advanced scientific instruments, the Lagrange points have journeyed from theory to reality. They are the invisible architecture of our solar system, special places of balance and opportunity. They are the natural stepping stones for humanity's expansion beyond our terrestrial cradle, the logical sites for the gateways, fuel depots, and construction yards that will form the backbone of a true spacefaring civilization. Ultimately, the Lagrange points represent more than just strategic locations in space. They represent a choice about our future. They are the quiet, stable crossroads from which we can either continue to gaze out at the universe or take the bold step of becoming a part of it. They offer us the chance to build new worlds, to create a self-sustaining multiplanetary future for our species. The journey will be long and difficult, but these 5 points of perfect balance, discovered through the power of human intellect, now wait for us. They are the launch pads for tomorrow's dreams, the foundations upon which we may build our lasting home among the stars.